Good morning, everyone. I don't know if you can see those little things in the bottom left, so I apologize if you can. Um, but this is just the screencast system. At any rate, today we're going to be talking about biodiversity and non-market valuation. Very exciting. So, of course, I figure we will start by talking about what's going on in the news, and then we'll go through what ecosystem services are, how biodiversity functions as an economic commodity, and then the value of ecosystem services, specifically focusing on non market values, which we'll get into later, some of the very basics of cost benefit analysis and how non market valuation works. And then we're going to look at one particular, piece of the puzzle called contingent valuation, which is a valuation method. And we'll talk about how that method works and some of the challenges with that method. So first off, in the news, it was interesting as I was looking around for news that had to do with valuation studies or with biodiversity and ecosystem services. I couldn't actually find a lot, at least not in the main media channels, which I thought was sort of interesting and spoke to the fact that we're not really using these methods as much as we could be, it seems. So, what I did find though was pretty cool. It was an article from 2015, so just a couple years ago. And the article was written by a researcher who was looking at the way our brains respond to contingent valuation studies. So she is a neurologist. Is that what you call it? She studies the way that our neurons fire. So she was looking at, so she did MRIs basically. And she hooked people's brains up to these electrodes. And then as she was doing her study, she looked at the brain activity when they were filling out a contingent valuation survey versus when they were making other kinds of economic decisions. And basically what she found was that the brain did not respond to contingent valuation studies the way it did to all other known classes of economic behavior. Meaning that when people are responding to these surveys, asking them how much they value these ecosystem services or biodiversity or a specific ecosystem, their brain is not functioning in the way that it would normally function to make economic decisions. So we don't know why that is. We don't know how it's failing to line up, but we know that it is failing to line up, meaning that contingent valuation surveys might be overestimating the value of that environmental asset, or they may be underestimating it, or they may sometimes overestimate and sometimes underestimate. But either way, we know now that this kind of throws into question, shall we say, whether or not we should be relying on contingent valuation surveys. And once you understand more of what those are, you'll see why. But this is definitely something to keep in mind when we get to the discussion later about whether or not this is a good tool. And I will say that right now it is the primary tool that economists use when trying to come up with the value of these ecosystems and services for policymaking reasons. So this is a really big deal, and I don't think it got a lot of attention, so I'm curious to know more about it. But at any rate, another great article. So what are ecosystem services and how is biodiversity a commodity? Well, ecosystem services are divided into these different categories. So we could lump them into direct and indirect services. So indirect services are all of the supporting services. Let me see if I can get is a pointer? No, that's not a pointer. Okay, well, so here we have our supporting services. Those are things like nutrient cycling, soil formation, primary production. So all of the natural things that have to happen in order to support these direct categories of services. So the direct services we have are provisioning, regulating, and cultural. Here we go. So the provisioning services, these are things like food, water, wood, and fuel, right? Any kind of thing that we're directly using that's being provided by the ecosystem. They provide these regulating services, so climate regulation, flood regulation, disease, water purification, and cultural, aesthetic, spiritual, educational, recreational. So we go out into nature and we get a direct service because of the beauty that we get to take in. For those of us who have sort of more spiritual or religious uses of the ecosystems and environments, that would be another cultural example, etc. So defining those, the supporting services are the underlying natural processes which enable the existence of ecosystems. The provisioning services are the material or energy outputs of those ecosystems. So any type of benefit that we can directly extract from nature is a provisioning service. The regulating services speak to the role of ecosystems in mediating or moderating our natural phenomena. So they're basically protecting us against disasters. So that's a regulating service that we are getting. And the cultural services are the non-material benefits of ecosystems that contribute to the development and cultural advancement of people. So whereas the provisioning means that we are actually using the raw materials, the cultural is we're not using or taking anything out of it, but just by virtue of its existence, we are able to derive some benefit from it. The regulating one is, I think, pretty clear, but also very different from those two in the sense that we are not directly using the regulated environment, but we are obviously benefiting from the regulated environment. So those are our definitions. So what about biodiversity? Where does biodiversity fit into this sort of schematic here? Well, you can see here that biodiversity doesn't really fit neatly into these classifications. It sort of floats around. It is cultural, but it's also supporting and regulating, right? Biodiversity is needed in order to create the basis for all of these other things. I might even argue that needed for provisioning, even though we don't directly use biodiversity per se. But greater biodiversity can regulate diseases and invasive species. So that's the sort of regulating function. It can also support many of the ecosystem functions that lead to provisioning and cultural services. The only way in which biodiversity, in my view, would be a cultural service is that for tourism reasons, right? We actually go out and we go to places that have high biodiversity in order to go see all of these different species. So for instance, you don't just go snorkeling anywhere, right? You're going to go to places where there are coral reefs and you're going to see a lot of fish, or where the conditions are right for more abundant, more beautiful fish. So biodiversity is this sort of interesting category that doesn't quite fit, but yet very much lends itself to all of them. So why is biodiversity then important from an economic perspective? Well, you might argue it's important because of all of these functions, but it's also important because of the type of commodity it is. So we're interested in understanding how biodiversity contributes in economic terms to human society. So remember, biodiversity, when we talk about it, is sort of an amorphous concept. We're referring to the number of species, right? How many different types of species we have. And so in and of itself, it doesn't provide economic value. But when you think about it in terms of commodification, it does provide a few different sorts of values we can think of. So we can think of biodiversity as a commodity in the sense of productivity, insurance, and knowledge. So what we mean by that is that natural systems that have more biodiversity tend to be more productive, meaning they make more of whatever it is that they're making. So this comes into play for us in agriculture. So when we have genetic variability in crops, meaning more biodiversity, different species of crops, it provides a greater pool for looking for those high yield varieties. So that means that we are able to find the ones that are going to make more for us. So in that way, the productivity of the biodiversity is a commodity. In an insurance sense, biodiversity defends us against disaster. So we think about this particularly in the context of climate change, that the more biodiversity we have, the better we are able to adapt to the changes that we're going to be incurring. So if we don't have very many species, again, you can think about this in agriculture. If we don't have very many species or strains of a certain crop, and then the conditions change such that that crop is no longer viable, we're in a big trouble, right? We don't have a lot we can do then in order to sustain ourselves. But if we've got a whole slew of varieties and a lot of biodiversity in what we're growing and the different species of those crops we're growing, then if the conditions change such that one of those is no longer viable, we still have several other viable species. So in that way, biodiversity functions as a commodity for us in the insurance it provides. And then lastly, in terms of knowledge, we can make items with commercial value based on the knowledge that we're getting from biodiversity. So for this, you can think of all different things that we have learned to make from the natural parts of our environment. So for instance, aspirin, little known fact, comes from the bark of the willow tree, or maybe you did know that. And we could go on and on about all of the different medical things that we have gotten. But if we start to kill off species, if we have less biodiversity, there's less opportunity for us to learn what we could be using to cure different ailments or just different types of energy we could produce. For instance, a couple years ago, I don't know if they're still doing this, but some of the major airlines like Virgin were experimenting with using algae to make fuel. And they actually got pretty far. They flew a commercial flight with algae. And I'll have to look up what happened to that. But it's a great example of how if we didn't have all these different types of things, we wouldn't know what we don't know. You know what I mean? So in that way, biodiversity becomes a commodity. So a question for you is, does the market system have the capacity to appreciate the economic value of biodiversity? Meaning, do you think that markets can sort of accurately commodify or quantify the economic value of biodiversity in particular, not an ecosystem service and not any one particular ecosystem, but just biodiversity? So this is the first of the questions we're going to ask you to fill out today. So for this one, just write a couple sentences. Doesn't have to be, a long earth-shattering thing, but just a few sentences on your thoughts about the market systems and the capacity to appreciate economic value of biodiversity. So that's number one. And I don't know if I should have mentioned, I think this should be clear by now, but your job throughout this video is to write down your answers to the questions that I ask and send them to me through Canvas. I will create an assignment. I've never done it before, so if I can't quite figure it out or if it's not working properly for you, just go ahead and email them to me because I'm going to be on a plane and it won't be able to respond. So just email me your responses if the assignment thing doesn't work. At any rate, so what is economic value? Economic value is anthropocentric, meaning that it is determined by people, not by natural law or the government. And it is determined first and foremost by people's willingness to make trade-offs. So we've talked about this before, but when you spend money on one good, there is less available for other goods. And this should remind you of a lecture a few weeks ago where we drew the production possibility frontier on the board. And we talked about how you have good A and good B, and you have to give up some of good A to get more of good B. But at any point along that curve, you're maximizing your preferences for goods A and B. So this is how we get the economic value, is how much you're willing to trade off in order to get that good. So we call that opportunity cost, right? How much we're willing to give up of one good or service to get another. So how much income are we willing to give up to get an environmental good or service is the opportunity cost of using that money elsewhere, like buying ourselves a pair of shoes, for instance. And I like this little comic strip on the right. It's just a funny depiction of opportunity cost, but you can see he says there, you know what would be really great? I'd love to see a matrix comparing the features of our past products. And then he says, okay, Dilbert, why don't you pull that together for the next meeting? Dilbert says, that would take 2 days and the matrix would have no practical use. The problem here is that Ted does not have any skin in the game. I propose that Ted has to bang his head on the table whenever he causes me to do extra work. That will help Ted make better decisions about the value of my time. Never mind. But so you can see that then there would be a trade-off for Ted. How much do I want to bang my head on the table versus how much do I really want this matrix made? So just a funny little schematic, but you get the idea. So when we're doing economic valuation of environmental things, it becomes a little bit more tricky. But the idea is that we are coming up with the sort of least cost path for optimizing our environmental and social gains. So economic valuation is a crucial part of the cost benefit assessment process, which is pretty vital in all environmental policy making. So we include health, social, and environmental data in these valuations. And the idea is that there are no externalities to inflate benefits and lower costs. And we use social discounting to reflect the present value and project true distributed gains across income groups and locations. And that gets into some pretty intense econ. So we're not going to get too deep into that, but suffice to say that we have to make decisions when we're doing all of these analyses and deciding how much we value these ecosystems. One of the decisions we have to make is how much we're willing to spend today to get environmental protection in the future. So if you think about almost any environmental problem, just like a cut that you get on your arm, it takes a while to heal or fix, right? So the benefits happen later, but the costs happen right now. You and I need to pay today in order to fix the problem that won't actually be fixed for a while into the future. And how long that is depends on what the problem is. So for instance, the ozone hole fixed itself actually relatively quickly. So you might have paid for those damages in 1987 when the law was passed, but by the 1990s, you saw the appreciable benefits. So you could see those benefits pretty quickly. When you come to something like climate change, we all have to pay for the damages that have been caused today, but we would not see the benefit of that for quite a long time, really. And again, seeing the benefit in something like climate change means that we don't see it. Does that make sense? It means that we don't see the damages that would have happened. So this is why we have a hard time coming up with the value of the damage caused by climate change, for instance, because it's really hard to figure out how much people are willing to pay today for something that is going to happen pretty far in the future, and they won't even see if we take care of it today. So anyway, we won't get too far down that rabbit hole. I get very excited about discounting, but it's an economic concept that gets very mathematical and complicated, and hopefully now you get the basic gist of it. So the way that we come up with this valuation, or one of the ways that we are going to focus on, is willingness to pay. We ask people how willing they are to pay to either minimize damage that has already happened or minimize damage that is expected to happen, or to improve the conditions from whatever baseline it is. So willingness to pay is the maximum that an individual would be willing to spend to receive a positive change in environmental goods or services. So as an example, if I tell you that the air in class is mediocre, not great, everyone in class can pay $5 and we will install an air purifying, humidifying, deluxe, what have you. I would ask you all, are you willing to pay $5 for this? You would all say yes. And then we would know that you are all valuing air quality at $5. On the converse, we have willingness to accept. Willingness to accept is the same idea, but it's basically the minimum that an individual will be willing to accept to receive a negative change in environmental goods or services. So an example here is if I said, okay, everyone in this class can get paid $5 to sit through class with no air conditioning this summer. And it would be up to you to decide, is it worth it to you to get paid $5 for worse environmental conditions? And obviously that's a pretty minor example, but basically you can apply these concepts to bigger, broader things as well. So for instance, you might ask a community, how much money are you willing to accept for us to put this landfill in your community? And here's the negative consequences. You'll have more methane in the air regionally, so you might have more truck traffic, you'll have more smog, therefore, aesthetic value depreciation. And then you ask how much they'd be willing to accept in order to have those sort of negative changes to the environment locally. And that would be a metric of how much they value their local environment. So both of these measures are income dependent, of course. So $5 might not be a lot to you, but $5 might be a lot to someone else, or vice versa. So we, of course, tend to see these correlations between income and willingness to pay and willingness to accept. So lower income communities are willing to accept less money in order to get or have to deal with an environmental harm. Wealthier communities will take a lot more money in order to acquiesce to having an environmental harm in their community. And then, of course, the inverse of willingness to pay. So people who have less money are willing to pay less in order to achieve environmental improvements. So the two are not always equal. Willingness to pay does not always equal willingness to accept. What are some of the reasons why this might be true? There are three main reasons why this might be true. So firstly, that people are sort of loss averse, meaning that people are more willing to accept money to keep their current conditions or get worse than they are to spend money to improve their conditions. You kind of adjust to where you're at, basically, is the idea. And so you're more willing to stay in your comfort zone where you are and get paid for that than to say, okay, I'll pay money to get even better conditions. Also, depending on how subtractable the goods are. So if there's a close substitute or not, not subtractable, substitutable. So if there's a close substitute, people are not willing to pay as much as they are to accept. And just general cluelessness. We don't know our own preferences all the time. So the calculations for these two come out to be pretty different sometimes. So how might you test this empirically? So you've talked with Kate a bunch about scientific methods and how you structure experiments. So this is the same idea, but it's a social science experiment. So a slightly different goal and different methods you would use. But I'd like you to write a paragraph thinking through how you would test if someone's willingness to pay was or was not equal to their willingness to accept. So you can think about any kind of environmental good or service or ecosystem. So you might pick Lake Tahoe. How much are people willing to pay to keep Lake Tahoe clean or to clean it up? And how much are people willing to accept to keep Lake Tahoe the same or let it get a little dirtier? That's just one example. You can pick any example that works for you and talk in just one paragraph about the steps you would take to test this empirically. The type of data you would need to get, where you would get it, what results you might need to see. No right or wrong answers here, really. Okay, that's number 2. Question number 2. Note, this is not measuring the value of the environment, but people's preferences for environmental protection. This is an important note. So ecosystem valuation is something entirely different. We come up with ecosystem service valuations in ways that are different from the way that we are coming up with these willingness to pay for biodiversity. So just an important note to bear in mind that this is also a social construct, like we've talked about before. It's how much people prefer environmental protection, not how much it is actually worth objectively. There is really no objective worth if we're going to get into it, but at any rate, just a note. So taking a step back, all of the discussion in lecture so far has assumed that we can put a dollar value on ecosystem services, and we call this valuation. So can valuation actually be accomplished in a meaningful, accurate way? This is not one of the email questions, but this is just a question for you to ponder right now. Can valuation actually be accomplished in a meaningful, accurate way? So the next portion is going to discuss that question, approaches to monetizing ecosystem services, and the challenges that we often encounter. And I would challenge you to really think, of course, it's easy to critique this, or at least it's easy to me to critique this. But if we don't have this, what do we have? If we don't have this valuation, what does that leave us with? That's what I would really challenge you to be thinking about. So, sorry, this is all blurry, but some examples of the dollar value we put on services. So provisioning services, the types of service provided is water for people, agriculture and grazing, vegetables and fruits, medicinal plants. And then we have these two values for developed economies and developing economies, and it's US dollars per hectare per year. So basically, we estimate that the value of water for people is somewhere between 45 to 75, it's quite a range, $7,500, dollars per hectare per year in developed countries versus about $50 to $400 per hectare per year in developing countries. And I don't know exactly how they derived these values, but it kind of goes to show that there's quite a range for most of these, right? So you can look at wildlife is somewhere between $40 and $520 per hectare per year. Roughly the same in the developing countries. Agriculture and grazing, somewhere between $3 and $370 per hectare per year. And same thing when you come down to the regulating services. So that's water quality control, flood mitigation, carbon sequestration, and we've got somewhere between double digits and thousands of dollars. So the point of this is to show that when we end up with these drastic ranges for values, it means that we don't have a lot of certainty. So when we go to use these values in our cost-benefit analyses or other kinds of policy assessments, what value we use can really change the outcome of our analysis. So if our analysis uses a value on the higher end here, that the value of biodiversity and provisioning is going to give us $7,000 per hectare per year for water, then that means that it's pretty valuable. And it's going to be unlikely that that policy isn't worth doing. Meaning, the higher the value that we're putting here on the environmental good or service, the more we're saying we want to protect that. We think it's important because it provides us a lot of value. If we're using these lower end values here, we're saying we don't think that biodiversity is that important because it doesn't provide us all that much value. So it's okay if we're going to go ahead and destroy it. Don't worry about it. So when we're doing environmental policy making, the higher the values that we're going to use in these assessments, generally speaking, the more likely it is that we will pass protective policies, because the higher the benefits will be of those policies in our cost-benefit analysis. And we'll get into that more in a minute. So what are these preferences based on? These preferences are based on direct versus indirect values. So the direct values that we get are the marginal changes in environmental goods and bads that have direct effect on utility. So it's direct sources of utility. Utility just means enjoyment, happiness, fulfillment. It's an economic term that sort of all-encompassing for quality of life. So an example is bird watching in the wetlands. If you are an avid bird watcher, then this is a direct value for you, having wetlands that supports biodiversity of birds. Another example is just believing in wetland preservation. Indirect value is measured by the role in production of the consumption goods and services. So an example, again, be the value of wetlands as a breeding ground for species or as a filtration device. So you're not getting a direct benefit from that wetland if it's just providing breeding grounds for species or filtering water, but it's an indirect benefit that you are getting versus the direct interaction you have with the wetland when you physically go there and you watch the birds that it provided the breeding ground for, it provided the food source for, etc. So note that the environment can have economic value without having a market price. So there's no price on the breeding grounds, right? It's not something that we trade, but it has value and we can calculate that value. So which of the following pictures depict direct value? So let's call this number 1 over here on the top left, and we'll go across. So 1, 2, 3, and then down here, the kid with the flower is 4, 5, 6, 7. So this is going to be question number 3. So I'd like you to say, for you personally, which of the following depict direct values? So 1, 2, 3, 4, 5, 6, 7, direct or indirect. So number 1 is a safari. So going out and watching the animals, is that direct or indirect? A bee pollinating this flower, direct or indirect? Going skiing in these beautiful mountains, direct or indirect? Stopping to smell or stick your whole face in the flowers? Salmon spawning, so salmon laying eggs, direct or indirect? People sitting under the shade of the tree, direct or indirect? And lastly, just a beautiful forest scape, just the existence of the forest, direct or indirect? Leave those up for a second. So you can write them down. I'll give you 20 more seconds so you can write down those answers. Sorry, maybe I should have paused on the other screens that I had the questions on. Okay, moving along. So our direct benefits, so that's again our direct use of those resources, is the sum of the use values and the non-use values. So I know we're getting a little confusing here with all the jargon, and we've got indirect and direct and use and non-use, but for the purposes of the class, the rest of this class, we're going to focus on direct benefits or direct uses, which are comprised of use and non-use. Meaning, use values reflect the direct use of the environmental resource. They can be consumptive, like eating fish, you are consuming that resource, or non-consumptive, like snorkeling. So you're not actually consuming the resource, but you are directly interfacing with the resource by going out and snorkeling to look at them. So it requires actual participation to enjoy use values. Non-use values reflect the common observation that people are willing to pay for improving or preserving resources they will never use. Example, preservation of unique, rare natural assets like the Grand Canyon. So let's take a little peek at non-use values. So again, multiple layers down here, but non-use values are the sum of the option, bequest, and existence values. Meaning, the option value is the premium we are willing to pay to retain the option of possible future use. So thinking back to those photos we just saw of direct uses, you might say, I have not yet gone on an African safari, but I would like to one day. So it's worth it to me to spend money today to have the option of one day going on an African safari. So it's a non-use value because you are not currently actively participating in using that resource, nor do you have specific plans to, but you want to have the option to. That's the option value. The bequest value is the satisfaction that people get from knowing that the natural resource is being preserved for future generations. So again, sticking with the African safari, you might really have no interest in going, but you want to know that your kids could go or your grandkids could go. So you might personally say, African safari, not my thing, or not a way that I want to spend my money, but I would be willing to pay to protect it because I want to know that it's going to be there for future generations to be able to enjoy it. That's the bequest value. And then we have the existence value. The existence value is sort of the most altruistic of the three, and it's the idea that people derive satisfaction from preserving natural resources just so that there is a habitat for fish, plants, wildlife, and so on. Meaning you have no plans or don't even want to have the option of going there. You're not necessarily thinking about future generations being able to go there. You're just thinking about the importance of its existence for biodiversity maintenance, for ecosystem functioning maintenance. So the value of its existence is important in the overall web. There is one more, which is actually the altruistic value, but we don't even talk about it because it's impossible to quantify. And frankly, there's so much philosophical debate around whether you can actually be altruistic. So we just kind of ignore it. So these are the three that we focus on. So which of the following represent use values to you? And which of the following are non-use values? So whereas before with the photos, you had pretty clear direct and indirect, this use and non-use is more specific to individuals, right? Because this is whether or not you are actively participating or planning to participate or whatnot. So just as a reminder, non-use is the sum of the option, bequest, and existence. Use is actual participation, either consumptive or non-consumptive. So this is question number 4. And these are the 7 questions. So touring the Egyptian pyramids, is that a use or a non-use value to you? Maintenance of obscure species of insects. Potential medicinal cures found in the Amazon rainforest. Eating goat brains, a delicacy in some African nations. Preservation of indigenous cultures. Panoramic vistas enjoyed from the terrace of a coffee shop in the Santa Cruz Redwoods. And protection of the Yangtze River in China. Which of those represent use values to you, non-use values? This is question number 4. And I will leave this up for another 30 seconds just to give you a little time to write these down. Actually, I'm going to grab some water really quick, so I'll give you 20 more seconds. I always feel funny recording these because I'm sitting here talking to an empty room. So I can't tell if you're looking at these and if you're thinking about them. So I'll assume you all have your thinking faces on. Okay, let's talk a little bit about valuation techniques. So how do we get these values? And why do we put values on the environment? Well, the primary reason, there's several reasons, but the primary one is to be able to do cost-benefit analysis. So cost-benefit analysis evaluates the effects of policy actions and the associated opportunity costs of those actions. So the favorable effects are defined as benefits, and the opportunities foregone define the economic costs. So the basic process is that you have to first identify the baseline from which you are measuring these costs and benefits. And then you have to come up with the policy alternatives. So we determine the scope of the analysis basically by saying, okay, the baseline is climate change continues unfettered. We're at 400 parts per million right now, or parts per billion. Yeah. And it's increasing. So the baseline is this increasing projection if we do nothing. And then we say, okay, here's the policy alternatives. Here's the different caps we could put and where it would bring the emissions down to. So that's determining the scope of the analysis. Then we describe quantitatively the impacts of the proposed action or policy. So, meaning we are going to put the dollar value, which we'll talk about how we do that, but we put the dollar value on those costs and benefits of those different policy options. And then we estimate the benefits and the costs of those impacts and compute the net benefits. So we take the benefits minus the costs, and that basically gives us our answer. So if the benefits outweigh the costs, then we do the policy. And if the benefits don't outweigh the costs, then we don't do the policy. So just to say a little bit more about this, so cost-benefit analysis gets confusing because we do it all the time without even realizing we're doing it, like deciding whether or not to get a coffee today. I do a little quick cost-benefit analysis in my head, like, well, it's going to cost me $3, which means I have $3 less for this. But it'd be really nice to be able to go to the coffee shop and get more work done because I like the ambiance. So, okay, that's pretty good. Benefit is my productivity, right? So we do these little analyses in our head in sort of unsystematic ways all the time. But what we're doing when we talk about environmental policy is we're trying to systematically come up with a way to evaluate whether the policy is a quote unquote good one, whether it's worth doing. So when we do cost benefit analysis in policymaking, we're not talking about the costs and benefits of climate change, for instance. We're talking about the costs and benefits of the policy to mitigate climate change. So that means that we're taking a policy, so a policy that, for instance, says we are going to put a strict cap on emissions that will bring us back down to 350 parts per, why am I blanking? Is it million, billion? At any rate, you know what I'm saying? Parts per million. That sounds right. And in order to do that, we're going to have all power plants, reduce their operations significantly. So what we're looking at is the benefits are all the avoided damages of climate change. If we actually brought our emissions down to the safe level, then the benefit of that policy would be that we don't have all of the bad things that would have happened had climate change been allowed to continue. But the costs of that policy would be all of the increased costs of whatever the factories or the power plants would need to do to reduce their emissions. So that means that, if they have to use new technologies that are very expensive, they're going to pass those costs on to consumers. If they have to stop operating, if they have to cut back on the benefits that they provide to their employees, all of those things are going to be costs. And then we'll have implementation costs and enforcement costs. So we have to hire people in order to make sure that the power plants are doing what they're supposed to do, right? We have to hire enforcement agents. We are going to have to make sure that we are informing everybody. So there's costs to that. So you get the idea that there's costs to the policy and then there's the benefits of the policy. And the benefits of environmental policies are avoiding all the damages that would have happened. So this is why it gets tricky to quantify the costs and benefits. So the costs, as you can see, tend to be easier to quantify. We know how much it costs power plants to operate. We know how much it would cost to use this specific technology. We know how much it will cost us to pay people to enforce these regulations. What we often don't know as well is the value of those benefits, the value of the avoided damages, or the value of the ecosystem service. So when we're doing this, that benefit calculation is crucial. And that's why when we talked earlier about those different ranges we get for valuation, That's why that matters so much. And that's why it matters how much we are valuing that future potential benefit versus the cost today. So anyway, we'll try not to get too into the weeds on the econ there, but this is the general values or gist. So how do we put values on the environment? There are two sort of broad categories of techniques. We have stated preference techniques and we have revealed preference techniques. So revealed preference techniques are based on actual observable choices where we can directly infer the value of the resource. So for example, the BP oil spill caused the price of fish to increase dramatically because people could no longer use the fish coming out of the Gulf. So, diminished the value dramatically. So that was directly observable in the price change of the good. We were able to see the change in the value from before the oil spill till after, and that was a way of revealing people's preferences for healthy, clean fish. Stated preference, on the other hand, is when the value is not directly observable. So we ask people, through surveys usually, how much they are willing to pay. So this gets back to that willingness to pay thing we talked about, for preserving the species, for instance, or the ecosystem, or whatever the good in question is. So it's a stated preference because we are asking people to state their preference versus revealing through their actions and the choices they make at the market. So there's a lot of different examples. This example is the northern spotted owl. A bunch of researchers asked people how much they were willing to pay to protect the northern spotted owl. It was hugely successful because people really like owls. They're a charismatic megafauna, so they're cuddly and cute. And they were basically able to use people's valuation of the northern spotted owl to reduce deforestation in the Pacific Northwest, because people valued the owl so highly and it only lives in that area. So anyway, we have these revealed preference and stated preference techniques. And then again, we have indirect and direct valuation techniques. So we are not going to get into these because these get all very econ-y. So we're going to basically ignore all the revealed preference methods. You can ignore those. This is just so you know what's out there, but we're not going to talk about them. We're going to focus on the stated preference techniques. So the stated preference techniques are choice experiments and contingent valuation, and they're basically the same thing. But we're going to focus primarily on contingent valuation because choice experiments are measuring people's preferences for specific attributes of the environment, whereas contingent valuation is measuring people's preferences for the environment as a whole. So for instance, contingent valuation would be more applicable to something like biodiversity, which is sort of like a big amorphous concept versus like how much do you value clean air versus clean water would be more of a choice experiment. So that will become a little bit more clear, I think, in a minute. But because we're focused here on biodiversity and sort of big ecosystem level choices, we're going to focus on contingent valuation. So what is contingent valuation? So it's the general approach that economists use to elicit willingness to pay for the total value of environmental assets. So the way it works is you describe the environmental impact that would happen with and without the policy or program. And the description has to be scientific, but understandable. So when you send out these surveys, people don't know anything necessarily. Sometimes they do, but because they're random, they don't necessarily know anything about the topic you're asking them about. So you have to inform them. But you have to make it be understandable to a broad range of people because these surveys are randomly distributed throughout the country. And as we know, there's people of all different educational levels around the country. So you have to have it be grounded in fact, but understandable for a wide audience. Then you describe the proposal or the policy that is going to minimize the environmental impact. So again, the description must be realistic and have a fair way to pay. And then you will describe the willingness to pay question. So the description can be open-ended, like the most your household is willing to pay, or it can be presented as a dichotomous choice. So the program will cost $10 per year. Will your family support the program or not? So dichotomous, just to be clear, just means either or, one or the other, binary. So here's the price. Will your family support this, yes or no? So there's different ways that we can present the willingness to pay question, which will obviously change the types of answers that we get. So stated preference technique, how does it work? Again, we ask people their willingness to pay or accept to bring about a specific environmental improvement. We specify the payment mechanism. So, for example, an increase in sewer fees, it could be through an increase in taxes, it could be through I don't know what other mechanisms are believable, but we can come up with some, I'm sure. And then you would sum up all the individual payments that people said they would be willing to make and come up with an aggregate measure of the passive use values to society. So in your survey questions that you ask people, you have to have a careful description of the goods that are being valued. So what would you be willing to pay for environmental improvement? For example, what would you pay for increased visibility in the Grand Canyon from 1 mile to 1.5 miles? The types of questions we can ask are open-ended, again, asking respondents for their maximum willingness to pay. Close-ended, asking them whether they're willing to pay a certain amount, which varies across respondents. Or what we call a bidding game, where we ask respondents whether they are willing to pay a certain amount. If they say yes, we ask about a higher amount until we find the highest that they are willing to pay. So the payment mechanism. Again, the mechanism has to be believable. So what does that mean? It means that if I tell you that you're going to spend an extra $10 a month to solve climate change, but you're going to put cash into a little lockbox in the corner of your neighborhood, you're going to be very skeptical, or you should be very skeptical of that program. That would not be a believable mechanism for paying for that improvement. But if I said it's going to be in addition to your state taxes every year, that might be a believable way that we're going to collect that money. The problem is that it should not be controversial. So there's a lot of things, even taxes can be very controversial. So the survey is not meant to serve as a referendum on the payment mechanism. You don't want it to be something that people are going to get really stuck on when they're taking the survey. So some of the aspects of payment mechanisms that you should consider are the nature of the payment. So utility bills, tax increases, the frequency. So people respond differently if it's a lump sum versus a monthly or annual contribution they have to keep making in perpetuity. And where the payment actually goes and who manages it. So does it go to a general governmental fund? Is there a third party that's in charge of managing it? Is it earmarked in a specific account? All of these things are important to take into consideration because they will definitely change the results that you will get. And then you have to aggregate up to the broader population. So first, you need to know what the relevant population is. So for example, if you want to know the willingness to pay to protect the right whale population in the Northwest Atlantic, do you survey citizens in New England, citizens across the country, or some other group? So if you're surveying only people, if you're surveying people across the country, you're probably going to get values that vary quite a bit from New England versus the rest of the country. If you're surveying people in New England and they're the only people who are going to be paying, then that seems like a relevant population there. So, but again, relevance can kind of be subjective or it can change depending on what you're looking for. So, for instance, I worked on a willingness to pay survey for the World Bank a few years ago, and we were looking at willingness to pay of people living in developed countries like the United States to preserve the Amazon rainforest. So, in that sense, for our research question, we wanted specifically to know how much money people from developed, wealthy nations would be willing to send down to South America. So, the relevant population to survey is the people who was going to be paying, which is the people in the US. And obviously, or not obviously, but theoretically, hypothetically, we probably would have gotten different responses if we had surveyed people in South America for various reasons. Even controlling for income bracket, people in South America who live near or in or rely on the Amazon rainforest are going to be willing to pay more to protect it than people who don't. So, relevant population really depends on the type of question that you're asking, and who would be involved in that. So, as someone who grew up in Connecticut and I am very attached to the right whales, I think that you would want to know people from New England what they're willing to pay to protect the right whale, because that's where the right whale is found. They're the ones who benefit from its existence. However, if you wanted to cast a broader net, you could, oh, no, not a net, not like that. I mean for the survey. Don't capture right whales. I heard they're actually going to be extinct really soon, and it was one of the most heartbreaking things I've heard in my lifetime. So go see the right whales. Anyway, should you expect different results? Yes, you definitely, obviously should. Those of us who grew up seeing the right whales are going to be a lot more attached to them than people, presumably from California, who have never seen the enormous, majestic right whales. Side note, when I was 8 years old, I used my piggy bank to adopt a right whale, and I believe that she is still alive. But that is unconfirmed. Okay, let's watch a little video of the valuation of ecosystem services. So I think this should work if I play the video. I don't know, you might have to mess with the volume on your end, but let's just give this a whirl. Hello? Okay.
This is a method for valuing ecosystem services by surveying people about how much they value the ecosystem service. Basically ask, what's the most you would pay to ensure that this remains like this, or goes from this to this? Or would you be willing to pay this amount, yes or no? Or check all the numbers that you would be willing to pay. Or likewise, what's the most you would accept in compensation to have this go from this to this? This could be an easy way to find out how people feel about an upcoming policy. Or we can analyze this stated willingness to pay to find out how much value the ecosystem service gives. The obvious rejection to the method is, how can we know that what they say they would pay is going to match how much they actually value it? Watching what people are willing to give up for something is how we determine the value equivalent. If they're just saying how much they would give up, how can we be sure we've gotten it right? How do we know they're not wrong or lying? And this problem is probably why people and policymakers respect revealed preferences methods over the stated methods. Don't have to worry about if this is going to match the real world. We are watching it in the real world. But it is the go-to method for measuring these other values that aren't typically revealed in behavior, the non-use or option values. And it's really the only method that can easily get the total economic value, capture people's willingness to pay for the whole area and everything about it. It can be hard to get it accurate, and there's a lot of things to consider. For example, the way people respond to hypothetical problems has a lot to do with how it's framed. For example, there was this one study that looked at PhD students and found that 93% of them registered early for a conference when they were told there was going to be a fee for late registration. But only 67% registered early when they were presented the situation as a discount for early registration. Same prices, but the responses to the situations was different depending on how it was framed. Also, if respondents don't genuinely think their stated willingness to pay will lead to a required pay in taxes or something, they may state a higher amount than they are actually willing to pay, strategically to try to up the stated value of the area. To overcome this, we can tell them they will be expected to pay the amount they state, or ask their income to make sure they're able to pay the amount. And otherwise, try to put them into a state of mind where they consider the choice realistically. But if respondents do think they will be expected to pay, they may answer with free riding in mind. Even though they do value it, they will state a value of 0 with the hopes that others will pay enough. Other people may be using the number field to communicate something else. What do you mean, pay for it? It's priceless. Or, this is a public good, it should be free to everyone forever. or yes, I want to protect this forest, all forests should be saved. Other people maybe wouldn't mind paying money for a thing, but if it involves a raise in taxes, suddenly they're against it. Basically out of protest to the question, they are putting in a very small or very large amount in that field, or even a realistic amount, but it's an expression of a different idea than the willingness to pay. Another idea is something called the warm glow effect. A person's willingness to pay may have almost nothing to do with the service. They just feel a value in giving. Fixing this might involve surveying people the reasons behind their answers, and sort through which reasons should be discarded because they don't reflect the willingness to pay. Finally, respondents may not have a precise insight into their own willingness to pay. For this, we can instead ask a range of willingness to pays, or choosing options from a list that can capture that uncertainty. And there's lots more considerations. But the goal is we really want to design a questionnaire that, when given to people, we are teasing out the most realistic willingness to pay that they can know about, and get good data coming in. This is a survey that was given out by mail in the state of Oregon in the United States. Actually asking the willingness to pay doesn't happen until the bottom of page 4. All this stuff before is to try to describe the situation and put the respondent into a state of mind where they are thinking about what they value about the area. To start off, they introduce by saying that they want the public's input on old-growth forests. Responses are confidential. They define what an old-growth forest is. Looks like they describe it as a forest that's been growing so long that it's old. Then they ask the respondent to reflect on what they may care about the old-growth forest. This is to help the respondent start to reflect on the characteristics about the forest that they like and what they value. And the researchers can later compare this to the amount the respondents say they are willing to pay. Now they introduce the issue of fire management in these forests. Some people think it's beneficial, others think it's harmful. How do you feel about this? Effect on beauty? Good, bad, or neither. And they start to introduce these non-use or difficult to measure values like the existence of the spotted owl habitat and diversity. And again, the researchers can compare this to the respondent's stated value. This describes the state of the spotted owl, endangered, and here are the critical habitat units that have been set aside from logging. This is Oregon. This is about 1/3 of Oregon. This talks about forest fires and old-growth forests in Oregon. Several $1 million are spent in fire prevention and control, but still about 7,000 acres of publicly owned critical owl habitat gets burned each year, around half natural, half caused by humans. And they say these fires can harm the forest benefits. So this talks about their proposed plan that will reduce by half the amount of owl habitat burned each year. It doesn't really communicate how it's going to work very well, though. And this is probably what made a lot of the respondents give protest votes. Maybe they couldn't see a connection between the money they're giving and the results promised. This describes the payment vehicle. Then the question, if this plan was voted in, would you be willing to pay this amount? Yes or no? So here it says $35, but there were 20 different amounts given on these surveys, ranging between $200 and $300. The idea is that there's a number of people answering whether they would pay at each price level, kind of like what you would get if you were using a traditional market-based approach, different amounts being purchased at different prices. It's just that here it's stated. And then they calculated the average willingness to pay based on this and their answers to some previous questions using this equation. I don't understand it. They also went on to ask what their maximum willingness to pay would be. They didn't use this number in their main analysis, but they could use it to catch when the person would say 0. Next page asks why they answered what they answered. Why they wouldn't. Program not worth anything to me. That's valid. Can't afford to pay. That's valid. I don't think the program would work. This idea isn't really capturing their value of the area, but rather their distrust of the program. It may be a valid point, but it's considered a protest vote. It's unfair to expect me to pay this, or I'm opposed to government stuff. Again, maybe valid points, but it's not capturing what the researchers are trying to measure, and they're considered protest votes. Reasons for saying they would pay. This program is worth at least this much to me. We have a duty to protect. I like good causes. I want to pay my fair share. They mentioned that these 3 may capture the warm glow effect, but they said that there was some debate about whether they should be excluded, and then they just kept them in. Perhaps because that warm glow feeling might actually refer to some of the non-use values that they're trying to capture. But in my opinion, this one, given to a good cause, doesn't really have anything to do with their value of the area. This is just them wanting to throw money at something. And I think if they answered that, it should be discarded. But what do I know? Anyways, do you do stuff in the forest? Various demographics. Then they thanked them, so they would know that their input was appreciated, and asked for further comments to give the illusion they care. Okay, so they dropped the protest votes and calculated the average willingness to pay from the rest. They found an average willingness to pay in their sample of $90 per year per household. They used this as the upper estimate for the willingness to pay. For a lower estimate, they assumed that all the people that didn't respond because their willingness to pay was 0. So their mean willingness to pay, with this assumption, was $45 per year per household. They noticed that there was a correlation between education level and the amount respondents stated they would pay. If they adjusted the average willingness to pay to match the education levels of the state, they get an average stated value of $77 per household per year. And they used this as a middle estimate. multiplied by the number of households in Oregon gives these estimates for the value of the protected critical owl habitat from fire each year. They also calculated confidence intervals and other statistical stuff, but we're not going to get into it. This was a simple example, but it's the general idea. In the next video, we're going to look at another kind of stated preference method.
Okay. So, some examples of values from contingent valuation research. Willingness to pay to avoid health problems. Came up with a value of $10 per asthma day reduced. Willingness to pay for better visibility, i.e. less smog. A 10% increase in visibility was valued between $7 and $10. Willingness to pay for cleaner water. The mean willingness to pay to improve water from boatable to fishable is $12.30. Mean willingness to pay to improve water from fishable to swimmable is $29.60. So you can see there how the way that we are using it will also change whether or not people are willing to pay for it, how much they're willing to pay. So these are just a few examples. Are these values reasonable? Are the results similar and consistent with the theory? Well, we do see that values increase when income increases, and that environmentalists are generally willing to pay more, which is what we would expect. Are the results similar to results from revealed preference approaches, looking at what people do with their money rather than asking them? In general, they do appear consistent. They're usually within one standard deviation, and in many cases, they're within the 95% confidence interval. So at least these studies and some others do indicate that willingness to pay is a pretty good technique for assessing the value. And in terms of reasonability, overall reasonability, to me, these are very reasonable values. But that's sort of subjective. But they're not crazy. So some of the types of biases, they touched on this in the video, but some of the types of biases that we see in contingent valuation studies are a strategic bias. So the respondent provides a biased answer in order to influence a particular outcome. So that's like a really intentional thing that people do, as he went over in the video. So sometimes people will sort of, why am I blanking on the word? I just lost the word out of my head. Not strike, protest. There we go. A protest vote, like we shouldn't have to do this. This should be done for us. So I'm going to say 0. Or, sometimes there's just, I'm going to say more so that it looks like we're really willing to spend a lot, or I'm going to say less so that it looks like we're willing to spend less, whatever it is. Sometimes there's actual strategic moves involved. There's non-response bias. So only the people who care about the issue one way or the other will respond to the survey, meaning you will most likely end up with extreme views on both sides of the spectrum. So either people who are really pro-development and really want to sort of shut down any policy that might restrict development, or people who are really pro-environment and want to promote the policy as much as possible. So you could end up sort of weeding out the more reasonable people in the middle who are willing to pay something, but just don't want to sit through a survey about it. So this is a problem in coming up with the value. And then, of course, there's survey instrument bias. So the form or the tone of the question can change how people respond. So, for example, do you think we should spend more money in order to ensure that our children receive a good education? It's going to make you want to say yes, right? Or if I said to you, don't you think that we ought to, would clearly bias your response. So in general, people making surveys, we try to avoid those things, but it's hard to avoid all of them. No matter how many focus groups you do, sometimes you end up with questions that do still bias responses a little bit. Excuse me, I have to sneeze. Oh, maybe not. Oh, no, I do. Hey. Ooh. Okay, maybe I don't. Okay, I did. Sorry. Excuse me. And then lastly, information bias. So respondents are being forced to value the attributes with which they have little or no experience. So The risk here is that the respondent will provide sort of casual, not well considered responses and will not consider their budgetary constraints. So, if I'm asking you how much you're willing to spend for something like the Amazon rainforest, which you presumably don't have much experience with, you're trying to come up with how much you value this thing that you've never experienced. So how do you know how much you value it? And you might not even be actively thinking, well, I make X amount of dollars. So what would that really mean? And then lastly, of course, he touched on this, but a big one is if you think you actually have to pay versus this is just a survey, who cares what I say on here, right? So one of the guys I worked with at the World Bank did a study where he sent people a willingness to pay survey, and then he actually sent them a sort of payment mechanism where they had to write a check and put a check and mail it to him. And the difference between what people said they were willing to pay and what they actually put on their check was huge. I don't remember the exact numbers, but it was definitely statistically significant and really, underscored this issue that what people say is not necessarily what people will do. So we've got all these kinds of biases and issues with contingent valuation studies. So some sort of examples of other types of biases is the starting point bias. This is the sort of how we ask the question. So this can come up in survey instruments in which the respondent is asked to check off their answer from a predefined range. So do you believe it is worth $1,000, $500, $2,000, $600, $3,000, $700? So where we're starting from is going to bias the responses that we get. And then anchoring. So whether we ask for the value of a seal and then a whale, or a whale and then a seal. So the first value given is around $100 and the second is around $50. So basically, this just means that the willingness to pay could depend on the order of the questions that are asked. So if I ask you first for 100 and then for 50, people will be more willing to say yes to the 50 because it seems like less compared to the 100. Or if I ask you about something you care about more, an animal you care about more, and then an animal you care less about, that kind of thing. Whereas the starting point bias, the difference is if I'm giving you these ranges, then, well, A, you have to pick something in between the range because that's the range I'm giving you. So your options are nothing or something in this range. And then how big that range is will determine where you kind of fall in the range. So 500 to 1,000 is a really little, small range. So the values are going to be more centered around the sort of middle. So at any rate, lots of different types of bias in contingent valuation studies. Oops, that was supposed to be around 600. Okay, so some of the content validity critiques. So what are we actually measuring? Respondents might be expressing value for a class of goods. So they might be sort of depicting their general preference for environmental quality, but not focusing on the specific thing that you intend for them to focus on. They might be measuring, or you might end up measuring their warm glow from supporting good causes, meaning that people might feel good saying yes to a good cause, even if it's not something they care about. So you're not getting their actual value of that thing so much as how much they value feeling good about themselves. Or you might be getting the value of people reacting to news like an oil spill. So do people really care about the resource or about preventing the action? So just because they're willing to spend X dollars to clean up the oil spill doesn't mean that they necessarily value the cleaner ecosystem so much as they just don't like the idea of oil spills, or they're opposed to companies who have oil in the first place, right? There's all these different things that they could be reacting to that aren't necessarily the thing that you're trying to measure. So there is some evidence for the whole idea of measuring the warm glow. So do people care about the number saved or just the act of saving birds? So a study attempted to find the answer by estimating the willingness to pay to protect migratory birds from oil waste pools by covering the oil waste pools with nets. So they said it would protect 2,000, 20,000, or 200,000 birds from dying. And they found that the values, the willingness to pay, did not increase with the number of birds saved. So if people really just cared about the birds, you would expect them to be willing to pay more to protect 20,000 birds, than 2,000 birds, or and even more for 200,000 birds than 20,000 or 2,000. But that was not the case. So one of the reasons why that might be true is because people don't actually care about the number of birds. They just care that they're doing something good. So protecting 2,000 feels as good to them as protecting 200,000. So some people point to these results as evidence of the warm glow effect. Proponents argue, however, that this could just be capturing diminishing returns, meaning protecting one unit of the resource is valuable, protecting another unit is less valuable, and another unit is even less valuable, etc. So if protecting 2,000 birds is enough to sustain the population, then why do we need to protect 20,000, for instance? But there's some evidence. So non-market valuation techniques and policies to estimate non-use values. So they basically, contingent valuation has been incorporated into some policies. So the CERCLA, the Comprehensive Environmental Response Compensation and Liability Act, that's the Superfund Act we talked about. It gives the federal government the right to sue for damages to natural resources for which they are the trustees. So basically, they are able to use non-market valuation techniques in these damages or assessing these damages. The Department of Interior in 1986 said that non-use values were recoverable if use values were not measurable. So basically saying that we don't just value our direct use of the resources, we also value those non-use values we talked about. And so to capture non-use values, we have to use contingent valuation. We can't really capture those any other way. So this was the first time that we really said, okay, this is a legitimate tool that we're going to use in these types of assessments and policy decisions. And then in 1989, a federal court of appeals directed the Department of Interior to redraft its regulations with equal weight on use and non-use values. So you can see that basically over time, we got closer and closer to really valuing contingent valuation and really appreciating non-use values. So originally, our environmental policy making, particularly in the 70s and 80s, was focused on our direct participation and use of natural resources. And we have since slowly moved in the direction of understanding the value of non-use values as well, and the importance, I should say, of accounting for non-use values. Because if we don't account for non-use values, only what we can use, the value of that ecosystem or biodiversity goes way down, right? A lot of this is stuff we can't use. We can't directly use biodiversity. It provides commodities, as we talked about, through knowledge in medications we can use, through insurance and protecting us from damages, through productivity and providing higher yield crops. But those aren't direct uses. So we need to account for those non-use values if we're going to accurately assess the value of an ecosystem and of biodiversity. So where does contingent valuation stand today? Well, NOAA, the National Oceanic Atmospheric Administration, assembled a blue ribbon task force to evaluate contingent valuation. As contingent valuation came under fire when it was used to calculate the damages from the Exxon Valdez spill. So that was 1989, at the same time that the Court of Appeals was using this use and non-use values, which is actually probably the result of that. So the NOAA panel concluded yes, but only if certain criteria are met in the design and application of the survey. So basically, yes, contingent valuation is something that we are going to use, but they have to design it and apply it in specific ways. So it is still controversial among economists, philosophers, everybody, but it is now a pretty highly sanctioned tool. this note about Deepwater Horizon. So that was the BP oil spill of 2010. So passive use values, the losses of the passive use values, are likely to be the largest component of that spill. So this is why this was a big deal at the Exxon Valdez spill, because it's not just the fish that we got out of that area, which there are a lot of, but it's also all of those non-use values or passive use values that we want to make sure we're capturing. So just a quick note on the sort of ecosystem services valuation front. A lot of economists and scientists have tried to come up with the value of the global ecosystems. So what is all of the world's ecosystems worth? And they've looked at, so this is one particular study that is kind of a foundational study from already 20 years ago. So take it with a grain of salt, but they looked at all of the services that are provided on Earth: pollination, raw materials, water supply, recreation, et cetera, soil formation. So all of those classes are in here, right? The provisional, the supporting, et cetera. And then they came up with this value, which you can see has quite a range. And I don't know the exact methods they use, so I would have to look that up. But the value they came up with for the entire global ecosystem was somewhere between $16 and $54 trillion. So to put that into context, the world GNP is $18 trillion at this time. So the last question, I guess this is question number 5, I think. And it's not written on here, so trick question. You would have had to actually listen to know this was a question. Please write and explain to me in just 2 sentences why it matters, or what it would mean if we were at the low end of that value versus the high end. So knowing the world GNP is 18 trillion, what does it mean if we are at the low end of 16 trillion versus the high end of 54 trillion in terms of global environmental policy making? So that I'm referring to international treaties, international environmental policy. It doesn't necessarily have to be climate change. Could be something like, the boreal forest that goes from Canada into the US. So it's still international. You've got 2 different governments managing the resource. So anytime we have these big global ecosystems, let's think about global. So tell me what it would mean to be at 16 versus 54. Very briefly, a couple sentences. And that is the end of what we have for today. So you've got an extra 15 minutes in which to answer all those questions and get them sent in. So again, I'm going to make an assignment, sorry about that, through Canvas. And if that doesn't work, just email to me. Okay, great. Thank you, everyone. Have a great day, and I will see you tomorrow.